Very good morning and warm greetings to everyone. Today we are going to see about what are the major difference between thin cylindrical shell and thick cylinders. You know that the thin cylindrical shell will have a wall thickness of less than d by 15 to d by 25. That is where small d is the diameter of the thin cylindrical shell. So the thickness will be very small. So in the case of thin cylindrical shell, the major stresses will be of the hoop stress or the circumference stress and the launch shell stress. So you know that in the case of thin cylindrical shells, the hoop stress or circumference stress can be determined from F1 is equal to PD by 2T, and the longitudinal stress F2 is equal to half of that F1, that is PD by 4T. So from that you can find the major and minor principal stresses. So here the major and minor principal stresses are hoop stress and the longitudinal stress. And here definitely in the case of thin cylindrical shell you have the maximum shear stress also. But you know that already we have seen in the case of thin spherical shell there is no shear stress, maximum shear stress on any plane. That is here F1 is equal to F2 for a thin spherical shell, that is equal to PD by 40. That is half of the hoop stress of the thin cylindrical shell. So here the thickness will be of either 2 mm or 5 mm or maximum of 5 to 8 mm. But in the case of the thick cylindrical shell, so here the thickness is greater than d by 15 to d by 25. So here the thickness will be of either 10 centimeter or 15 centimeter, or sometimes it will go up to 25 centimeter, because it has to carry a lot of internal pressure due to either fluid or any, in the case of energy, that is heat energy stored, or in the case of boilers you have to give the shield also. So here the stresses will be determined by using the Lami's equation. That is a very famous equation in the case of thin cylindrical shell. So the thickness is very high compared to the thin cylindrical shell or thin spherical shell. But in the case of thin spherical shell, there is no shear stress at anywhere section of the shell, because wherever you take or cut the section would be of a circular one. So thickness would be of 2 to 5 mm in the case of a thin spherical shell. But in the case of thick spherical shell, it will be used to store the heat energy or the boilers, or in the case of the the energy due to the atomic energy to storage rate. So for that we had to design the cylinder as a thick cylindrical shell. So the thick cylindrical shell will be designed based on the Lami's equation to go for the various stresses acting on that. So that we can see it in the next video, how to find the stresses and strain, and also the changes in the dimension or the volume of thick cylinders. So that is the main difference between the thin cylindrical shell and the thick cylindrical shells or the spherical shells. So we can see the design or the stresses determination of thick cylindrical shell in the next video call. Thank you very much for patient listening. வாழ்க வையகம் வாழ்க வளமுடன்.